morning, students. Welcome to our first EJC online class. Today, we are happy to have with us our special teacher that will be doing math with you. And math is very excited, right? Yes, Mrs. Russell from the Agley Park Preparatory School will be here, and she'll be walking you through a very interesting topic. But before we do that, I'll ask you wherever you are just now to bow your heads as we pray together. Our master teacher, we come before you at this time to thank you for watching over us through the night and for us allowing us to see yet another day. In spite of all the challenges around us, we know that you are in control. And so as we're about to begin our math class today, we invite your spirit to be with us. Give our teacher wisdom, knowledge, and understanding, and may all the students be blessed for Christ's sake. Amen. Over to you, Auntie.
Okay, good morning, everyone. I hope you're all feeling well and hope you're putting on the math brain. My name is Auntie Carlita. I'm from the Hagley Park Prep School. This morning, we'll be talking about ratio. Before I go any further, I want to share my objectives with you. My objectives. Can you read with me? Our objectives are: use ratio to compare quantities in two sets. Next one, write a ratio using the formats, and there are three formats there. In our lesson, we will go further with them. Write a ratio in its simplest form. Write equivalent ratios for a given ratio. And the last objective, solve problems which require the use of equivalent ratio. Now, before we go any further, we want to come up with a working definition for ratio. What is ratio? Okay. What is ratio? Now, on my table here, I have some manipulatives. And we know we can't do maths without showing, because children, when you see, you're able to connect. Okay, first I have some sets of blocks. The colors are red and yellow. How many yellow? How many red? Okay, so we have four yellow blocks and 3 red. Sorry about that. 3 red. Now we want to compare in terms of the amount that is there. So we're working towards getting a working definition for ratio. Very good. Stay with me, don't leave me. So we have 4 yellow blocks and 3 red blocks. How can we compare them? In terms of how many red, how many yellow. So for every 3 red blocks, you would give me 4 yellow blocks. So that would be a 3 to 4. Hope you are getting me. For every 3 red blocks, you're going to give me 4 yellow blocks. I'm going to go to the next set of manipulatives that I have. 2 gold balls and 5 red balls. Comparing them, for every time I have 5 red balls, I will give you 2 gold balls. So what is ratio? Based on what the instruction or the demonstration, what is ratio? Now, ratio is a comparison of two quantities. Let us go back to our table. Comparison of two quantities. Can compare in terms of colors and compare in terms of the amount, the quantity. 4 yellow to 3 red. With the gold ball, 2 gold balls to 5. So we are comparing. We compare. A ratio is a comparison of two quantities. How can we write a ratio? We can write a ratio in 3 ways. First, we can write a ratio as a fraction. Second, using the word to. And 3, using a colon. We have the ratio 4 yellow balls. So we are going to write 4 yellow balls to 3 red. So we're going to use it with the colon. 4 to 3. So this is one way we write ratio with the colon. Another way we can write ratio is as a fraction. Very good. So we have 4. So this one is a fraction. So we can write it as a fraction. Or what's the other way? Okay, we can write using the word to. 4 to 3. 4 to 3. So the 3 ways we can write a fraction. What are the 3 ways? What are the 3 ways we can write a fraction? A fraction, a ratio, sorry, my mistake. A ratio, 3 ways. A fraction, we can write it as a fraction. We can write it using the word, so as a fraction, using the colon, or using the word to. Please look on the screen and I'll have an example. Using the colon, 6 to 8. Instead of using the colon, we can use the word to. 6 to 8, or 6 is to 8. Or we can write it as a fraction. 6/8. Now we're going to do an example together. Okay, on the screen you're seeing how many circles? Count them with me. You would have seen 7 circles. How many squares? There are 5 squares. Very good. And how many clouds? That's my clouds. Don't laugh. I know you can do better. There are 3 clouds. Okay, very good. Now we're going to see if we can compare these objects. The first one asks us to compare circles to squares. What would be the ratio for that? And as we go on, you're going to write or sketch your answer somewhere, maybe in a book or so. And we're going to go through all 7 before I show you my answer. Number 2, you're asked to write circles to clouds. Remember how many circles? How many clouds? Number 3, clouds to circles. Number 3, clouds to circles. Number 4, circles to all figures. And I want you to note that part. Circles to all figures. All the figures, now you'll have to count the entire figures to know how many is there. Number 5, clouds to all figures. Number 6, all figures to squares. And number 7, squares to all figures. Okay? I know you're ready to share your answers with me. So we're going to go back from number 1. Okay? Did you get that? Circles to square. How many circles we have? 7 circles. How many squares? 5 squares. And we said that we can write the ratio 3 ways. So we have circles to square, 7 to 5. So that's using the word 2. Can we write it as a fraction? Yes. 7/5. So this is it as a fraction. Can we write it using the colon? 7 to 5. And this is it with the colon. I also want to point out to you students that when you're asked to write the ratio, the order in which the ratio is given is important. Please do not change the order. So we go back to our first example, circles, square. If you are change the order and change it to say circle, squares, circle, that's not what you are asked to do. You are asked to find circles, square. So you have to stick to the order. It's very important that you stick to the order in which the ratio is given. Otherwise, it would be incorrect. Let us go to our number 2 example. Number 2 is saying circles to clouds. 7 circles to 3 clouds. How can we write it as a fraction? I'll allow you to do that. How can you write it using the colon? I'll allow you to do that. Remember what I have on the board? The 3 different ways we can write the ratio. Now, if you are not asked for a specific way, you can write it using any of the ways that you are given. Any of the 3 ways. Sometimes you'll be asked for a specific way. If you are not asked, you just choose one off. And then you'll explain why you choose or state that we can write ratio using any of these ways. Number 3, clouds to circles. Okay, 3 to 7. Becoming easier now? I hope so. Number 4, circles to all figures. All figures is compiled of how many? 15. And how many circles? 7. So we have 7 to 15. And this way we are comparing a part to the whole. A part of the whole to the whole. All right, and that is the fraction, another way you could say it. Then we go to number 5, clouds to all figures. 3 clouds to 15. 15 represents all figures. Write it, we can write it whether as a fraction, using the colon, or using the word 2. Number 6. All figures to squares. So notice the order. Look at number 4 along number 6. Remember what I was saying, that the order in which you write your ratio is very important. So number 4 says what? Circles to figures. But number 6 say now what? All figures to squares. So the order in which you write your ratio is very important. Number squares to all figures. And number 6 and number 7 is somewhat related. Realize that. They put the squares to the front for number 7, so they have now squares to all figures. The order in which you write your ratio is very important. Okay, we have another one. For this activity, it says that there are 30 students in a class. I know I have more than 30 students today, but there are 30 students in a class. How many are girls? There are 14 girls in this class. We are going to be unpacking the prompt now. What do we know? Okay, we are given 30 students, so we know that there are 30 students. Do we know how many are girls? How many are girls? Okay, 14 girls. And we need to find out what? How many are boys? So we don't know the number for boys, so we have to find out how many are boys. How are we going to do that? I know some of you are very bright, as I would say. So you just look on it and you just know it like that. But we don't want to leave anybody behind because we are working together on this thing. So we are going to subtract it and show our working. So we have 30 and we take 14 from it. Okay? 14 from 30 and we would get 16. And I know somebody will be saying, 16, miss, how did you get that? How did you come up with 16? All right, because I don't want to leave anybody behind, we're going to take it step by step. Okay? So we know that 4 from 0, we can't. So we have to do some renaming. So we're going to rename. We're going to take 110 from there, from the 310, and put it over here, over the ones area. So we are renaming. So it now becomes 10. So we say 4 from 10, we're left with 6. And 1 from 2, we're left with 1. So how many boys is in the class now? Very good. We have 16 boys. So we are finished unpacking the prompt. And students, I'm going to say this. Whenever you get a math question, the first thing you need to do is ask yourself, what information I'm given? What information is relevant to complete this problem? And also, what do I know? So we'll go back to our question. The class has 30 students. That's what we know. The class has how many girls? 14 girls. What we need to know is how many boys. So we work it out, and we got 16 boys. Now we can go in writing our ratio. So they're asking us now to write the ratio girls to boys. I'm saying it again. The order in which you are given the ratio and for you to write your answer is very important. So we have girls to boys. Write your answer. Then we have boys to girls. Okay, I see. I hope your pencils are getting busy. Then we have girls to all students. Remember how many students are in the class? All students. Then we have boys to all students. Okay, we are ready. And I'm going to ask you just to give yourself a little tick with your pencil. Or if you have your reading pen, no problem. You just go ahead and give a little tick. Okay, we're going to go now with our answers. So we unpack the prompt. We're getting somewhere. Girls to boys. Very good. 14 boys to 16 girls. You notice there's an extra equal. There's an extra equal which says 7 to 8 or 7, 8. Can anybody say what we did there to come up with that answer? All right. I think I heard somebody saying, simplify me, simplify. But we're getting there. We're getting there. So if you have that, give yourself a tick. Very good. Number 9, boys to girls. We have 16 girls, 14 boys. You have that. When you write your answer using the word to, or you write your answer as a fraction, or you write your answer as using the colon. Doesn't matter which one because I did not say which one, all right? Then it says girls to all students. How many students are in the class? 30 students. How many girls? 14 girls. That the equal sign is saying, and it says 7 to 15. What did they do there to get that? Still hearing somebody in the background. 7. And we simplify. We are getting there. Then boys to all students. 16 boys to 30 students in the class. Okay, how many persons got all correct? 4. 4 out of 4. All right, very good. I hope you are understanding so far what we are doing. Remember, we are comparing ratio using the word to, the word fraction, writing it as a fraction, or using the colon. Then I'm at the part where we talk about simplifying our ratio. Now, when we talk about simplifying, we mean we're going to break down the ratio in its lowest term. We don't want it to be too big. We want to make it smaller. So we're going to go back with how many boys in the class? 14 boys and 16 girls. Now, with simplifying, you will need to know your factors. Not just factors, knowing your factors, but you have to know your highest common factors, or some will say greatest common factor. So we are writing, it said 14 boys, 14 to 16. What are the factors? Common factors for 14 and 16. Common factors, when we say factors, a number that can go into both numbers without leaving a remainder. So timetable is very important. And not just knowing the timetable, I want it now to apply the timetable. So our highest common factor, do you agree with me, it's 2? Yes, so 2. So can we get 2 into 14 without leaving a remainder? Yes. 2 into 14 would end up with 7. 2 into 16, okay, would end up with 8. So we say this fraction, we simplify. When we simplify, we break it down, make it smaller. Okay, let me just highlight this. So we simplify our fraction, our ratio, sorry. We simplify our ratio. On your screen you will be seeing now, we have a ratio to simplify. Write the ratio, 15 bikes to 9 skateboard in simplest form. What do we know? Remember, we unpacked the prompt. What do we know? We know that there are 15 bikes. So that's what we know. And there are 9 skateboards. So we're going to write it as a fraction. Bikes to skateboard. So we write the ratio as a fraction. Okay, work with me. I'm going step by step because I don't want to leave anybody behind. Then we are going to simplify. And when we simplify, we need to find our HCF, or our greatest common factor. The greatest common factor for 15 and 9 is 3. So we're going to divide, and with a fraction, we know that the fraction must have a numerator and a denominator. So whatever you divide the numerator by, you divide the denominator by the same number. So we divide 15 divided by 3. And 9 divided by 3. And then we would get 5/3. Or 5/3. But remember, our denominator names our fraction, so we say 5/3. The ratio of bikes to skateboards is 5:3. And I show you there where we write it, the 3 ways. Remember, ratio can be written in 3 ways. As a fraction, using the colon, and also using the word to. Here's another example. Write the ratio 24 shirts to 9 jeans in its simplest form. Giving you just a minute. Remember, simplest form, we are going to make it smaller. We are going to find our highest common factor for both numbers. So we write it as a fraction. Then we simplify. Good. Our highest common factor here is 3. So we are going to divide both the numerator and the denominator by 3. And we'll get 3/8 or 8 over 3. The ratio of shirts to jeans, we can write that using the 3 ways: as a fraction, using the word colon, or using the word to. We're going to practice. And I'm sure before you were happy that you got all 4 correct. So we're going to see if we can get all 3 correct here. 15 cows to 25 sheep. Remember the first thing, we write our ratio as a fraction. Okay. Then we simplify. And in simplifying, we find our HCF, or same as you say, your greatest common factor. And what's our HCF for 15 cows to 25 sheep? Very good. 5. 5 would be our HCF. So I'm going to go to the board. Hope I'm not leaving anybody behind. 15 to 25 sheep. So the first thing, we are going to write our ratio as a fraction. 15. Then we are going to simplify. Very good. You are with me. And remember, when we are dividing, we divide both the numerator and the denominator. We say our highest common factor is 3. So we are simplifying. 3 into 15, 5. 3, sorry, thank you. 5. 5 is our highest common factor. Thumbs up to that student. 5 is our highest common factor. Very good. Because if you realize, if we use 3 into 15, if we use 3 into 25, we would end up with a remainder. Very good. And we don't want to have a remainder because we want to find a number that is common to both the 15 and the 25. So very good. Very good. I can see that you are following with me. So our highest common factor is 5. 5. Very good. 5 into 15, 3. 5 into 25 goes 5 times. Agree with me? Very good. So we get our answer 3/5. And remember, we can write the ratio as a fraction using the word to or using the colon. So we are saying 15 cows to 25 sheep. When we simplify that ratio, it would be 3/5, 3 to 5, or using the word 3 to 5. All right. 24 cars to 18 trucks. Okay, giving you another minute. 24 cars to 18 trucks. So remember, the first thing we do, write our ratio. Then you write your ratio as a fraction. After writing your ratio as a fraction, you are going to simplify. In simplifying our fraction, we need to find the HCF, or the greatest common factor. Very good. So we have 24 and 18. 24, so the ratio, 24 cars to 18 trucks. We're going to write our ratio as a fraction. Then we are going to simplify. Simplifying, we need to find our HCF. 24 and 18. What's the HCF? Okay. 3. 3 is our highest common factor. 3 into 24 goes 8 times. And 3 into 18 goes 6 times. What do you realize? Because somebody was saying 3, so I go ahead. But what do you realize with the end product? You realize that you still could cancel or still could simplify. And this is what I want you to do. When you're working a problem, you would have finished here like what I have here. But you would realize that, no, I could go much smaller because this is not in its simplest form. So you would have to get your eraser and go back and say, what did I miss? So I have 24 and 18. What are the common factors? So one way, in order not to make any mistake, we could find our common factors. 1, 2, 3, 6. They are common to both 24 and 18. But the students stop here with 3. Would that be our highest? No, miss. So our highest would be 6. And this is it, students. When you're working a problem, you make a mistake, nothing is wrong with starting over. We are not perfect, so you just go back over and see where you went wrong. I know sometimes in rushing, you might say the wrong thing, but it's good when you check over your work. So we go. Good. 6 into 24 goes 4 times. 6 into 18, very good, goes 3 times. Is that now in its lowest term? Yes. Yes. Follow the steps. Think you're going wrong? Just list your factors and find the highest common one. Okay, then we have 30 knives to 27 spoons. What would be our highest common factor there? Okay, I see some hands just popping up. 3. 3 would be our highest common factor. So our ratio in its simplest form would be 10 to 9. Did you get that? 10 to 9. So give yourself a mark if you got all 3. Congratulations. Give yourself a pat on the shoulder. Very good. Very good. Now we can also write a ratio using writing ratio as equivalent. When we say equivalent, they are the same. So I'm going to go back to my table. And I want to take out, I'm putting these away. When you compare these two balls, we have 2 red and 2 gold. They are equal, 2 sets that are equal. Same thing with the blocks. 2 sets of blocks, 2 red and 2 yellow. So when we say equivalent, we are talking about equal. Ratios that make the same comparison are called equivalent ratios. Equivalent ratios represent the same point on the number line. To check whether 2 ratios are equivalent, you can write both in its simplest form. And we have been doing that, writing ratio in its simplest form. And I heard somebody with their hands, maybe their face like this, how to get equivalent ratios. Wow. I'm not leaving anybody behind, so we are going to work together. So there are steps that we must follow. And I must stress this, children, in doing math, you must follow the steps. Because with our exams now, we are asked to explain. We are asked to explain. And when you explain your answer, the more you explain, the more marks you will get. When you explain also, you put your answer in sequence. So you go step by step. All right. So how do we get equivalent ratio? Step 1. A number of you are at home now, school out, and you have been playing games with your friends, with your brothers, your sister, maybe your neighbor also. And in playing the game, you will have some winners and some losers. So we are playing a game. And in the game, we have 3 winners and 7 losers. I want to write that ratio 3 to 7. I would say that we must write our ratio when we are finding the equivalent. We are going to write it as a fraction. Step 2, we are going to simplify. We're going to simplify our ratio. Step 2. All right, I'm not seeing step 2 coming up. Sorry about that. Step 2. Okay, we're going to see what we can do to get an equivalent ratio. Now for this step 2, you notice that we multiply the numerator and the denominator by 2. We multiply the numerator and the denominator by 2. What are we finding again? The equivalent ratio. So 3 multiplied by 2. Okay, we would get 6. And 7 multiplied by 2 would end up with 14. Okay, so multiply both the numerator and the denominator by 2. Okay. Step 3. Okay, says 9:21. There's a typing error, but we will go on. So multiply, the next step, multiply both the numerator and the denominator by 3. The two ratios are equal to the ratio of winners to the losers. So the two ratios, they are equal. If we simplify both the ratio, 6:14 and 9:21 would end up back with 3:7. So they are equivalent. Good. Are the following ratios equivalent? We have 4/5 and 12/15. Are they equivalent? All right. Now, one easy way to find out if they are equivalent is that when the two fractions are multiplied, the cross. So let me go to the board. Okay, so we have 4/5 and 12/15. We want to find out if they are equivalent. One of the easiest way, we multiply on the cross. Cross multiply to find their product. 5 times 12, 60. 4 times 15, 60. Are they equivalent? Yes. Because when we multiply them across, we get the same, which is 60. So let us go back to our slide. In pink at the bottom, you would see two fractions are equal if their cross products are equal. Emphasis again. Two fractions are equivalent if their cross products are equal. Just like what I did here on the board. Let us look to the board. The cross product, they are equal. Cross product, 4 times 15, we get 60. 5 times 12, we get 60. The cross product are equal. Yes, they are equivalent fraction. So we can continue with other examples, stating whether they are equivalent. So first, we divide 3/27. We divide the numerator and the denominator by 3. We would end up with 1/9. 2/18. We're dividing both the numerator and the denominator by 2. Did we get 1/9? Okay. What can you say about the 2 ratio? Are they equivalent? Okay. Somebody is saying, let us go to the cross product and try it if we would get it. So we have 1/9 and 1/9. Let us go to our cross product. 9 times 1, 9. 9 times 1, 9. So they are equal. So they are equivalent. Let us go to the next example. Example B. Okay. So since 1/9 is equal to 1/9, the ratios are equivalent. Very good. So we have 12/15. Okay. When we divide both the numerator and the denominator by 3, what would be your answer? Very good. 4/5. Well, remember we have 27/36. So we can't just stop there. We have to do the other one. What are we going to divide both the numerator and the denominator by? Wow. Very good. I have some bright students today. I like that. I like that. Then we have 3/4. Did you get that? Yes, I can hear the sounds coming in. Very good. You're doing well. Proud of you. Okay. Since 4/5 is not equal to 3/4, the ratio, are they equal? No, miss. Very good. They are not equal. The ratios are not equal because when we multiply, find our product. So we have 4/5 and 3/4. So we are going to find the product. 4 times 4, 16. Correct? 5 times 3, 15. Are they the same? Are they equal? No, miss. Very good. So this is what you show. Use that symbol to show that they are not equal. All right. You can take these two from the board. You can take these two and you're going to do them on your own. And I thought our next session we will go through with them. All right. Now the question I'm going to ask. Can we find ratio in the Bible? Yes. Using the 10 Commandments, students, how would you write ratio? The 10 Commandments, we know the 10 Commandments is divided into 2. Love to God as against love to men. There are 4 commandments, that the first 4, love to God, and then the others, love to men. So we'll write it 4 to 6. The animals that went in the ark, the clean animals against the unclean animals. The clean animals went in 7 by 7, and the unclean animals went in 2 by 2. Can you think of others that we can find in the Bible? Just write them. Or you can just simply upload your answers to us. Okay. So we know that in everything we do, we have to incorporate and remember that God gave us the wisdom, the capacity to do the math. All right? So there is a little quiz for us. And based on time, we'll just run quickly through the quiz. Okay, write the ratio in its simplest form. 22 tigers to 44 lions. A ratio for that is, in its simplest form, is a half. Or if you write it any of the other ways that we looked at earlier on. 5 feet to 14 inches. Okay, 30 to 7, very good. And that is in its simplest form, because the highest common factor there would be 1 for both numbers. They said write the ratio that is equivalent to each other. These are some possible answers that I think you would have come up with. Possible answer for the other part. Okay. Then there's a second part to the quiz. Simplify to tell whether the ratios are equivalent. Remember, we did something at the examples. Yes, they are equivalent. Can you say why they are equivalent? Okay. Very good. Then we have the other, number 6. Very good. They are not equivalent. Very good. So we're going to go Katie Porn, number 7. Yes, they are equivalent. Both equal to 1/8. Both equal to 1/8. So we want to make the application now. Why do you think we need to know about ratio? And how can you apply ratio to your everyday life? In choosing a career, ratio can also assist you. So those of us who like to bake, you like to bake, I know all of you baking at home, those chocolate chip cookies, very good. You will need to know more about ratio. Okay, and I'm going to tell you, next time we meet, we are going to go further into ratio. See you next time. And again, my name is Carlita Russell from Hagley Park Prep. And we are going to pray before we end. Let us pray. Kind Father who art in heaven, we give you thanks for what you have been doing for us. Lord, I ask you to help each boy and each girl that have been listening. They would have learned something. Thank you again, Lord, for technology that we can use it to impart education and also point our boys and girls to Christ. Amen. Thank you.
Good job.